This is a pre-built version of the application. So if we go ahead and run the server and two clients, and this will be the server, and this the first client, and this one the second one. And Alice will pick this number as her prime number P, and this one as her alpha primitive element, and for her private key D from this set she will pick this number, and she calculates her public key beta and sends all that information to Bob. So P, alpha, and beta. And Bob in turn will pick this as his prime number P, and this number as his primitive element alpha, and this one as his private key D. And he calculates his public key beta and sends his information to Alice. And here we are running in ASCII mode, so Alice and Bob can only exchange ASCII messages. So let's say Alice wants to send this ASCII message to Bob, and let's use this as her one-time private key for this message. So she calculates her one-time public key or ephemeral key for this message, and the one-time masking key for this message, and she is using I to do that, and the alpha for Bob and the P for Bob. And she uses the masking key to encrypt the message and obtain this ciphertext Y, and she sends the ephemeral key and the ciphertext to Bob. And Bob in turn receives the ephemeral key and the ciphertext and uses the ephemeral key to calculate the masking key for this message, and then uses the inverse of the masking key to decrypt the ciphertext message and obtain the original message X. And if Bob wants to send this ASCII message to Alice, and using this one-time private key, so he does the same thing. He calculates the ephemeral key and the masking key for this message, and uses the masking key to encrypt the message, and sends the encrypted message and the ephemeral key to Alice. and she receives those and uses a ephemeral key to calculate the one-time masking key, and uses the inverse of the masking key to decrypt the message Y and obtain the original message X. And passive Eve can see all the communications. So now she have P alpha and beta for Alice, and same thing, P alpha and beta for Bob. And she can see this encrypted message with the ephemeral key going from Alice to Bob. But in order to decrypt it, she needs to obtain D or I, and in order to do that, she needs to solve one of two discrete logarithm problems. So either she has to obtain D and solve this discrete logarithm problem. So log base alpha of beta in mode P, and then uses D to calculate the masking key, and then uses the masking key to decrypt the message and obtain X, so using the inverse of the masking key. Or she could solve this discrete logarithm problem, log base alpha of the ephemeral key in mode P, and obtain I, and then uses I to obtain the masking key, and same thing, uses the inverse of the masking key to decrypt the message Y. And same thing here for the message coming from Bob and going to Alice. And before proceeding with the code, let's do a quick summary, and let's also show that when we do decryption, we obtain the original value of X. So the setup here is Bob wanting to send a message to Alice, an encrypted message to Alice. So we start with Alice selecting a large prime number P, and then she picks a generator alpha in ZP star or a subgroup of that, and third she picks a private key D in 2 to P minus 2, and then she calculates the public key beta, so alpha to the power of D in mode P, and she sends P and alpha and beta to Bob, and Bob starts by picking a private key I in 2 to P minus 2, and then he calculates the ephemeral key, which is alpha to the power of I in mode P. And third, he calculates the masking key, which is beta from here to the power of I in mode P. And he encrypts the message X using the masking key. So X multiplied by the masking key in mode P will give us the encrypted message Y, and he sends Y and the ephemeral key to Alice, and Alice starts by calculating the masking key, so this would be congruent to the ephemeral key to the power of D in mode P, and then she uses the inverse of the masking key to decrypt the message Y. So here we want to show that Y multiplied by the inverse of the masking key in mode P will end up giving us x, so it's congruent to x. So we start the y and we replace that with x multiplied by the masking key. And for the masking key here, we replace that with the ephemeral key to the power of d. So we have the inverse of that. And we replace the masking key with beta to the power of I here. And the ephemeral key with alpha to the power of I. And we replace beta with alpha to the power of d. So we end up with alpha to the power of d to the power of I, and here alpha to the power of I to the power of d, and the inverse of that. So we have x multiplied by alpha to the power of di minus di, so x multiplied by alpha to the power of 0, which would give us back x in mode P. I will start by creating a new Java project. And to do JSON, I used this jar on this previous project. So we'll copy it and go to properties and Java build path. And we will have two packages, one for the server code and another one for the client code. And on the server side, we will have a server class with a main method, and a server thread class which will extend from thread. And on the client side, we will have a client class with a main method, and a client thread class, and it will extend from thread, and El-Gamal logic will be in this class. And this class will have those three instance variables which will be initialized in this constructor that takes in a socket and a server. And here we are using the socket to initialize the buffered reader, and we are also using it to initialize the print writer. And the server will have two instance variables, a server socket and a set of server threads, and it will be listening on this port for incoming client connections, and when a new connection comes in it will accept it, and we will have a server thread that will handle communications with that client, and we will add that server thread to the set of server threads, and we would call the start method, which will end up triggering a call to this run method when the operating system decides to do so. And let's add this method here that forwards messages from Alice to Bob and the other way around. So here this server thread is handling communications with a specific client. So it's picking up JSON messages and indicating if it is a message that indicates what are the public key for this client, then passive Eve indicates that she can see that, so P, alpha, and beta. Otherwise, if it is a message that contains encrypted message and the ephemeral key, then passive Eve indicates that in order to decrypt that message, she needs to obtain D or I, and in order to do that, she needs to solve one of two discrete logarithm problems. So to obtain D, she needs to solve this one, and to obtain I, she needs to solve this one. And if she is able to solve this one, then she can use it to calculate the masking key, and then she can use the masking key to decrypt the message. And same with I. If she obtains I, then she can use it to calculate the masking key, and then use the masking key to decrypt the message, or the inverse of the masking key. So this should do it on the server side. And on the client side, this class will have those instance variables, so it will keep track of its name and the other party name, and P and alpha and D and beta for this client, and P and alpha and beta for the other client. And this flag indicates that this client is ready to send and receive messages, and this flag indicates the type of messages that we can send and receive. So if it is true, then we can only send and receive ASCII messages. And here we have get and set methods for those instance variables. And we have two static methods. This one turns character to ASCII, and this one turns ASCII to character. And the client thread will have those two instance variables, and the constructor takes in a socket and a client, and we use the socket to initialize this instance variable. And the Gamal helper class will have a client instance variable, and it is initialized in the constructor. And this method handles communications. So here we indicate if we are running in ASCII mode, and for the purpose of this tutorial we will be running on localhost, and the server will be listening on this port. And when we call start here on the client thread, we will end up triggering a call to this run method when the operating system decides to do so. And this method handles incoming messages. So here we are picking up P and alpha and the name and beta from the other client, and in this case we indicate that we are ready to send and receive messages. And here we will have those two static methods to handle encryption and decryption of messages. And this method handles the setup phase, so picking up P and alpha and the private key D from the user, and sending them to the other client in a JSON object. And this method that handles incoming messages ends up calling the decrypt message, this static method. And this is the code for this method. So here we are sending the ephemeral key and the encrypted message as a JSON object. And here we pick up the one-time private key from the user, and we use that to calculate the ephemeral key and the masking key for this message. And here we call the static encrypt message on the Elgamal helper class. And we call this method from here. And finally, let's go ahead and test run the application. So this will be the server, and this one the first client, and this the second one. And Alice will pick this P prime number and this primitive element alpha and this private key D. And she calculates her public key beta and sends her P, alpha and beta to Bob. And Bob picks this P and this alpha and this D, and he calculates his public key beta and sends all that information to Alice. And if Alice wants to send this message to Bob, and maybe she picks this private key, so she calculates her the public key for this message, or the ephemeral key, and the masking key, and maps the character to ASCII and encrypts the ASCII message using the masking key, and sends the encrypted message and the ephemeral key to Bob. And he receives those and calculates the one-time masking key for this message using the ephemeral key, and decrypt the message using the inverse of the masking key, and obtain the original or maps the ASCII to character and obtain the original message coming in from Alice. And let's say he sends this message to Alice and maybe picks this one-time private key. So same thing, he calculates the one-time ephemeral key and calculates the one-time masking key and then maps the character to ASCII and uses the masking key to encrypt the message and obtain Y, the encrypted message, and sends the ephemeral key and the encrypted message to Alice. And she receives those, calculates the one-time mask key, and then uses the inverse of the masking key to decrypt the message and obtain X, and then maps the ASCII to a character and obtain the original message coming in from Bob. And passive Eve can see all the communications, so she have P, alpha and beta for Alice, and P and alpha and beta for Bob, and she can see this message coming from Alice and going to Bob, and in order to decrypt it she needs to solve one of two discrete logarithm problems and obtain D or I, and so she can solve this discrete logarithm problem, log base alpha of beta in mode P, and obtain D, and then use D to calculate the masking key and use the masking key or the inverse of the masking key to decrypt Y and obtain X. Or she can solve this discrete logarithm problem and obtain I and use I to obtain the masking key, and same thing, use the inverse of the masking key to obtain the original message X. And here we're doing the same thing for a message coming from Bob and going to Alice.